I have the honor of presenting Johannes Schimpelsberger, who is Senior Contract Officer with ESO. Most welcome.
Thanks very much for being received here in Sweden. My name is, as Maria said already, Johannes Schimpelsberger. I'm working in the ESO, in the administration. And we are basically doing the competitions and contracting of companies, of suppliers, for services and supplies for ESO. The more, let's say, formal part will come afterwards, the more interesting part maybe also for you in the sense of how to get into business with ESO, how could I, which possibilities are upcoming, how could I start being in business with ESO. But first of all, I wanted to show you a video which gives a little bit of a visual impression on what we are doing, what is our main topic. So just to say it shortly, it's astronomy. That means basically we are operating and building telescopes. They are in Chile on high mountains because of the dry conditions there, so that we simply have the possibility to optically observe at the best conditions, and that's naturally on a high mountain where the atmosphere is thin and where it is not raining and not wet and nearly all the time sunny and not disturbed in the atmosphere. Yes, so here I show you this video.
The European Extremely Large Telescope, or EEOT for short, will be by far the largest optical and near-infrared telescope in the world. In early December 2014, the ESO Council gave the go-ahead for the first construction phase of the telescope.
This is the ESOcast. Cutting-edge science and life behind the scenes at ESO, the European Southern Observatory.
Astronomy has reached a point where bigger telescopes, much bigger telescopes, are essential to address many of the important unanswered questions. For nearly a decade, ESO has been working together with its user community of European scientists to design such a new giant, the EEOT. The decision by the ESO Council means that crucial contracts, including those for the construction of the dome and the telescope structure, can be awarded according to plan. The EEOT will have a main mirror 39 meters across. It will collect 13 times more light than any other optical telescope today. This main mirror will not be a single mirror. Instead, it will consist of 798 hexagonal mirror segments, each about 1.4 meters across, but only 5 centimeters thick. The EEOT has an unusual optical design, using 5 mirrors. This includes advanced adaptive optics that corrects the fuzziness of astronomical images that is caused by atmospheric turbulence. Adaptive optics are already in use at ESO's Very Large Telescope. By using this technique, the EEOT will be able to produce images up to 15 times sharper than those from the Hubble Space Telescope. The EEOT will feature a suite of state-of-the-art science instruments to capture the light that the telescope collects. The dome of the EEOT is an exercise in superlatives. With a height of 74 meters, and a diameter of 86 meters, it simply dwarfs any existing telescope enclosure. The perfect future home for the EELT has been found on the summit of Cerro Armazones, a 3,000-meter high mountain only 20 kilometers from ESO's Paranal Observatory in northern Chile. On the 19th of June 2014, part of the peak of Cerro Armazones was blasted away as an initial step towards leveling the summit. Since then, the work on the mountain, as well as on the road from Paranal to Armazones, has progressed well. The construction of the telescope itself will take about a decade. Once in operation, the EELT will tackle some of the biggest scientific challenges of our time. It will image planets around other stars and study their atmospheres looking for biosignatures. The EELT will also make fundamental contributions to cosmology by measuring the properties of the first stars and galaxies in the universe and by probing the nature of the mysterious dark matter and dark energy. On top of this, astronomers are also, in a way, expecting the unexpected. Surprising results that cannot be anticipated today. The European Extremely Large Telescope will represent a gigantic leap in our ability to observe the universe around us. The world's biggest eye on the sky will lead to a wealth of new discoveries, and it will revolutionize many areas of astronomy. This marks the dawn of a new era.
So, thanks very much for watching this, and thanks very much to our public relation people who are really doing a lot of work on these things. You may also look to the website of ESO and find more on such information. They're really very active and using new technologies and everything, which we are not so much in the administration departments. Yes. The topics addressed today is to know ESO, because maybe there are quite some people who don't know yet what ESO is doing, who don't know so much about our projects. That's why it helps a little bit to visualize, to see what are we doing. Information about what business possibilities we have, contract values, what we place, what's our values, what's budgets available, tendering procedures, what tools we use, and the industrial return also here touched, which we had a little bit of discussion already before. So yes, as I said already, ESO is doing astronomical research. We build and operate telescopes. We have astronomers, we have scientific people also as staff members in ESO. And these people are maybe the most important ones, because they really do the result of all what we put into the mountains, all what we established there. Yeah, and then the ELT project, just to make a little bit of a joke about the abbreviations. ESO, for example, is with the long title, the European Organization for Astronomical Research in the Southern Hemisphere. So we call it simply ESO. That's a bit shorter. And the ELT is the European Extremely Large Telescope. Extremely large because it's a 39 diameter mirror, which is consisting of segments. and which is different to what we had before. Before we had the ALMA project, which is radio astronomy, which is also in Chile on the Atacama Desert. And we had the Paranal Observatory, which you see here in the middle. And then you see in comparison the size of the ELT. So that's really quite a big difference. And also in terms of construction time, in terms of budget, in terms of efforts which we have to put to place such a tool on the Chilean mountains. The administration, the defining of the specifications, all these things are basically done in the headquarters in Munich. We have also people in Chile. We have also offices in Chile, in Santiago. But tendering is on the European side, basically. So the total investment for this telescope, which is basically the third or the fourth one which we are building, is 1.1 billion euros. This 1.1 billion euros probably will not go all to Sweden, but at least a part of it could go to certain contracts in certain areas. That's why I wanted to explain a little bit which areas we are dealing with for the ELT. So that's simple construction. That's the dome and main structure. Simple not because it's a big project. It's nearly in the size of a football stadium. So there is steel structures, there is coverage, there is motors for the movement and of the machining and mirror support structure. There's basically an enclosure which needs to cover the telescope installations inside this dome. Then we have the optical things, mirror blanks. I have already talked to a company here in Sweden who is interested in M1 segments and work together with the future contractor for that. So also this material we need to get from somewhere. This material needs to be polished. So there is a very important superficial coating on the mirrors, which needs to be perfectly fine to really be in specifications with the optical quality. And there is the support of the segments. There are position actuators, which are important to correct the atmospherical disturbances. We have lasers. These lasers you have seen shortly in the pictures. They point on the sky and they make a reference, an artificial reference in the sky in order to measure atmospherical turbulence. And then we need to correct these turbulences by slightly, really slightly, moving the coating, the superficial, the upper part of the mirrors, really only slightly, in real time with dedicated computer programs, so that these atmospherical turbulences are corrected and we have the best optical results. Yes, then the mirror cells, detectors for the instruments to get the light inside and to collect data which is coming from the sky. Basically, the instrumentation is not really, like we said before, in kind, but it's also a cooperation with institutes, with European institutes, where they develop and produce the cameras, the instrumentation, which is used for the data which is created by the telescope. And there is also, that's competitive in any case, but it's universities, institutes, whatever publicly funded locations in Europe. And also for this, there is the possibility, because they make procurements also, that interested companies can participate to and deliver to these institutes. They are known soon because these are identified institutes who are developing these instruments. And if they procure, if they need parts, if they need mechanical things to construct the instrumentation, the instruments, then there is also the need for proper suppliers for these institutes. Yeah. Then the design of the power station, which will come later. But in any case, also electricity is needed, infrastructure is needed, road is needed, service contracts are needed, and quality assurance to really make sure we do the proper things and we define properly our requirements. Yes, so that's just shortly to show what we normally place. That was in the Alma time, let's say, because from 2005 there was the big part of Alma procurements. We also look at the member states. We try to have contracts in the member states, although you see there are US contracts also in Chile. Naturally, Chile is also with the infrastructure, with the services, with the maintenance and the local things we need there. Yeah, then the size of the contracts. You see there are not so many bigger than 5 million. And that leads us also to the point, okay, we have 1 billion of investment value, but the contracts are contracts which are in the size of whatever, up to 5 million, or some of them more than 5 million. But it's not simply one contract with one big supplier who has hundreds of sub-suppliers. We really do that at the time we need it, and we go to the market. The selection of the bidders. On the one hand, the ILO function, so that companies come to the ILOs, tell them, I'm interested, I have to offer these and that possibilities, and they contact us. We can set the bidders on the list. The ESO database, which is a big database on experience, let's say, and on also interest expressed by the companies. One has to say also that the ILOs make suggestions to ESO in terms of selective tendering. We have the same as it was explained also for CERN, that we do not simply open a call for tender where each and every company who is interested, even if they are rather just looking around without very much detailed aim, let's say, or a very low-priced dumping offer has to be taken into account. So the selective tendering avoids that by qualifying beforehand. We have a list of companies, we get suggestions, we get statements of interests. We put these companies on the list, they get invited, they get qualified, and then they really get the commercial tendering documentation to really provide their offer and to apply for the contract. Here it's important to mention that we need, for whatever field you would be interested, your best offer, the lowest, because we still have for both, for the supply and for the service contracts, still the lowest priced offer is the one which wins. Out of the ones which are technically compliant, which fulfill all the criteria, which should not very much be above the requirements, because that's more expensive. So really the criteria which are specified, which you get in the documentation, which you get in the requirements, they should be fulfilled, and out of these companies which are evaluated to fulfill this, the lowest has to be taken. So that's still in our rules and regulations, and that's why it's important really to look also at the price. We are technology driven, and we really need good technology, but we need it at the best price. Exactly what it says here. We also apply the basic procurement principles, obviously. Also, ESO has a proper and own set of financial rules and regulations and procurement and sales procedures, because we are originally even coming from the location of CERN, and we have then been given by the German government a location in Munich, where ESO is located since the 70s, late 70s, I think. Yeah, the fair distribution of the contracts among the ESO member states, that's the important topic which was already mentioned before also. We don't have a established system of this percentage needs to go in this country, this percentage needs to go to that country, so that in the result, like ESA sometimes does, that in the result we steer and we control the geographical distribution. That we don't do. We really let the market play, but what we can do is to give certain chances to companies, to countries which are underrepresented. And if we see that Sweden or Czech Republic or Austria or whatever needs better geographical return because we run the statistics on it, we are very happy to have at least the full set of the 5 companies on the list which we can use and invite for a tendering procedure, which means to increase the chances that one of these gets the contract afterwards. There is the possibility exceptionally to do real targeted tendering. So that means if we have an underrepresentation, we can only go to 1 or 2 countries which are underrepresented. That's really exceptionally and needs to be justified and quite an internal procedure. The procurement tools are request for information, which is similar to a market survey, which is a very light approach. That means just you provide what you can deliver, which technical requirements you can fulfill, and there is only a basic documentation available on the technical side. It's the first step, that's to see what is available on the market, and that's then to go into the further tendering procedure. The preliminary inquiry is the qualification. That is also not yet with the full set of documentation. The call for tender is really then the commercial offer and the technical offer, and that's what has as a result to put the contract in place. And then price inquiries are for smaller competitions with below 150,000 euros. Very important just at the end to mention here the advance info website of ESO. Here normally you can see which procurements are in the near future planned. They are all listed there. And even if you would not be prime contractor, but be a sub-supplier, you can see what is done. And you can ask the ILOs, you can ask us, and you can check whether there is any possibility to contribute as a supplier, as a sub-supplier, or whatever other setup is interesting for you. That we mentioned already, the return coefficient and geographical return. Yes, thanks very much.
Thank you. Perfect. Thank you very much. We are soon going to go for a coffee break, Martin. We will take you after the because we need to get another presentation in. But this is fascinating. You are going to look for planets outside the 9 planets in our own solar system, which is, of course, looking for extraterrestrial life, which is very interesting for those of us who love astronomy. But did you say that this is the size of a football arena?
Yes, you can compare more or less. If you see at the previous,
That's astounding. Yes.
yeah, if you see here the cars, for example,
Yeah.
it makes a little bit of impression. What's the size?
Yeah. Amazing, amazing. And for Swedish companies, what are you exactly looking for? If somebody came here and said to you, I can deliver X or Y or Z, where would you make a little jump of joy?
For everything.
For everything, yeah.
Yes.
Yeah.
No, because we need Swedish contractors,
The contractors, yeah.
and it's really, even we measure also geographical return also for the not being prime contractor. That means if you work together with a prime contractor and there is a certain revenue going to Sweden, it's also something which contributes to the geographical return. Everything means even services, even IT, big data, programming, consultancy, not only really the structuring or optics of the telescopes, there is many things connected with it also.
And the basic procurement philosophy is like with CERN, go for your lowest price and then think about it as a long-term relationship.
Fulfill the requirements as
Yeah.
excellent as possible, but without overshooting in order to keep the price at a competitive level.
At the competitive level. Okay, we have to say thank you to Johannes and good luck with this absolutely stunning project. I think all of us would love to visit.